Hi, welcome to Unit 4 Topic 3 Video 7 and the final video on the Hungarian algorithm to do with maximal problems. And this question is a solving for a maximum problem question because we've been doing minimums so far. That's not a big step. So let's have a look. 4 salespersons, A, B, C and D, are to be sent to visit 4 companies, 1, 2, 3 and 4. Each salesperson will visit exactly 1 company and all companies will be visited. Previous sales figures show that each salesperson will make sales of different values depending on the company they visit. These values are in 10,000s of pounds. It's a UK question again, so we're using pounds. Doesn't really matter. As shown in the table before. So we've got Anne, Brenda, Connor and Dave. Really common to use that A, B, C, D thing. And company 1, 2, 3 and 4. And there's our estimate of sales. And of course, Anne earning 26 for company 1, that's the estimation, well it's in 10,000 pounds, so we're talking about 260,000 pounds. But we're going to stick with the 26 for now. Part A, use a Hungarian algorithm to obtain an allocation that maximises the sales. You must make the method clear and show the table after each stage. Right, so welcome to my prepared slide area here, and again I've prepared as many as I think I need, and you might have some prepared for you in the exam. Now I'm going to show you a method for finding the maximum. It's one of a few methods, so you're welcome to have a look around. You could ask your teacher for any other methods and see which ones you like. I'm just going to show you the one that I think works nicely, and it also means you don't have to memorise as much. It's one routine. What we're going to do is map this to a minimum problem. So what I'm going to do is, if I want to maximise my values here, what I want to do is minimise my distances to the ceiling. And when I say ceiling, I mean to the maximum value I've got here already. So the maximum earnings I could make are person A at company 2 makes £300,000. That's the 30 there. So there's 30, there's heaps of 30s and they're my maximums. So what I'm going to do is I'm going to represent them as minimums by just doing a really simple 30 minus, I've really mucked that up, let's forget that's even there. 30 minus each cell, so each value x, where x is each of these values, and create a new one. So let me show you what it looks like and then we'll talk about it a bit more. 30 minus 26 is 4, 30 minus all the 30s there is zeros, 30 minus all the 30s here are zeros, here's me doing the easy ones first, and then I've got 30 minus 23 is 7, 4, 1, 5, 3, 6, 3, 5, 9. So what this is saying is that if I pick person D to go to company 4, I only make 21, which is 9 less than my maximum. So I lose 9 on a potential. It's like a potential loss. And I want to minimise my loss. Now, it's not technically loss, but it's a nice way to think about it. I want to minimise this value. So what I'm going to do is I'm going to take this matrix and minimise my allocation, and that will provide me a maximum allocation here. So I'm just going to reverse it, and I just did it through that. 30 is the maximum value there. Subtract each cell from 30 to get a new set of cells. Now, I'm just back to an old question I've done before. So let's do this. Step 1, row allocation. Now, I'm going to show you something. I'm going to show you that we can skip step 2 because I'm feeling a bit lazy and I have limited space. So, row allocation first, or row reduction first. Row A, it's got a 0 in it, which means that I take away 0 from everything, leaving me with the same row. Row B has a 0 in it, same thing. 0, 7, 4, 1. Row C, 0 in it. 0, 5, 3, 6. Row D, 0 in it. 0, 3, 5, 9. Now, in your exam, you're really not going to be punished for being a little bit lazy. It's good in maths to be trying to be timely and efficient. So you just have to justify everything you do. Now, if you've got time, I'd probably do all these steps, even though we've not changed anything here. And if you're a little bit short of time, you could probably just say, look, I don't need to do this step. There's a 0 in every row, so the reduction's not going to happen. I'm going to skip step 3. By step 3, I mean step 2, sorry, which is a column reduction because there's a 0 in every column. So every minimum is going to be 0. I'm going to subtract it from everything, blah. It's going to be gone. I'm going to go straight to step 3, which is n equals 4. Can I cover with less than 4 lines? And I can see that I can. There's my less than 4 lines. Only 2 lines. I've got one double here, and I've got a heap of singles there. And my minimum, since I've started circling them now, so I better finish, my minimum is this 1. So I'm going to be subtracting 1 from these guys, adding 1 to the square, and then leaving the zeros the same. So I get a 5, 0, 0, 0, 0, 0, 0, and then I get subtract 1, 6, 3, 0, 4, 2, 5, 2, 4, 8. Can I cover again in lesson 4? Yes, I can. 1, 2, 3. These are my double ups. These are my no covers. My minimum is 2, or that 2 there, and I'm going to do it again. So I add 2 onto my double ups, which gives me a 7 and a 2. I'll leave these ones the same. 0, 0, 0, 6, 3, 0, 0, 0. There's a lot of zeros now. I'll subtract 2 from these. 2, 0, 3, 0, 2, 6. Now, I can get rid of 3 there. Oh, I can get rid of 2 there, but you know, I can't get rid of those 3 in one go. So there's not much I can do now. I can see that I cannot do this in less than 4 lines. So I'm left with, oh, that was silly, wasn't it? I had to go there and there, really. I'm left with using 4 lines. So now I can do my allocation. I've got A, B, C, and D. And I've got 1, 2, 3, and 4. And A can match to 2, 3, or 4. B can match to 2 only, so I can already see a bit of a way in here. C can match to, B can match to 2 only, sorry, that shouldn't be there. B can match to 4 only. Now C can match to 1 or 3, and D can match to 1 or 2. Okay, so now the first thing I'm going to do is I'm going to recognise that B has to be 4. And that wipes out this one. But the problem is that A can still be 2 or 3. C can be 1 or 2. And so C can be 1 or 3 and D can be 1 or 2. So I could do my matching again here just to clear things up. I've got A, C and D left. 1, 2 and 3 left. A can be 2 or 3. C can be 1 or 3. And D could be 1 or 2. And so I'm left with that matching where there's still multiple going to each one. So I've actually got 2 solutions. Solution 1 is coupled with B goes to 4. What if A goes to 2? If A goes to 2, then D can't go to 2, which means D goes to 1. If D goes to 1, then C can't go to 1, which means C goes to 3. Or option 2 is A doesn't go to 2, A goes to 3. And then C goes to 1 and D goes to 2. So they're my 2 options. And in terms of minimising, B has to be 4. So I'll come over here with my orange one. B has to be 4. So B is definitely there. But then I've got 2 options. Either A is 2, D is 1, and C is 3, which gives me a maximum of 30 plus 30 plus 27 plus 29, which is max 116. Or the other option is 3, 1, 2. So that would be 3, C is 1, and D is 2, which gives me 30 plus 30 plus 27 plus 29, which has also got max 116. So you'll notice here that this is part A to the question done when we've done our allocations. And then our part B and C, we've kind of done them already. So part B says what is the maximum, and the maximum is 116. But if we go to the context, it's 116 times $10,000. So that would be 1.16 million pounds, sorry, not dollars. And then part C says, show that there are more than one option. Well, I think we've done that. Our bipartite graph here does that really well, and we've shown that these 2 options give the same maximum. And so therefore there's 2 options. Okay, so that's a maximum problem. Hopefully that made sense and it helps and that you can apply that. You should definitely go and crack into those now, those questions. The Hungarian algorithm is a really good source of complex familiar, complex unfamiliar questions, and so I think you're pretty capable of doing those. Have fun. Well, thanks for joining me on that adventure with maximal problems. There won't be many of them, but it's definitely worth knowing how to approach them, and this is at least one method. All the best.